Hello world, and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, architect at Winelect, and today we're going to be looking at how to use Windows containers and also how to use Windows containers with Azure Kubernetes Services. Hi guys, I'm going to be reintroducing myself back into my videos now that I have a new utility that allows me to record myself using my camera and using my microphone in the same app, because Canon released a new driver for the camera and the Windows PC that allows me to use my camera as a video source in third-party applications and allows me to select my microphone and use that for my audio, so I can bring those together while I'm recording it rather than having to record them in two different apps and bring them together in video editing software, which is incredibly laborious. Thank you, Canon, so much for releasing this utility. It allows me to cut down my video editing time a lot and saves me a lot of effort, so I can now do this and not have to worry about having to use the Canon's camera microphone. I can use this one, which is much better for recording my voice and not having real echoey and really low sound when I use the camera microphone. So thank you, Canon, again for doing that. I really appreciate that. And this is also my streaming setup, so maybe I can use this for live streams in the future. Who knows? We'll see what goes forward. But anyways, while you're here, let's get into that. That has to do with Windows containers and Azure Kubernetes Services. So this week, Microsoft released into general availability the ability to run Windows containers on Azure Kubernetes Services. Now that feature has been in preview for some time, but now it's been GA'd, so you can now create node pools on Azure Kubernetes Services that are for Windows containers. And I'm going to show you how to do that in a demo here. And then also for my demo, what we're going to look at is how to use Visual Studio to create an application, say an ASP.NET application, and use Visual Studio to create a Docker image, push that to a registry, and then we're going to use the control command line to push that up to Kubernetes services, and then we will then deploy the app doing that. So that's our demo for today. So let's switch over to the Azure portal and take a look at how you can create a cluster using Windows containers. I'm here in the Azure portal now, and I have before me a AKS cluster that has already been deployed, and I'm going to create a new cluster, or not actually go through the process and click create. I'm going to go through the wizard and show you what you need to turn on to create a cluster so that you can use Windows containers with the cluster. But I'm going to come back to this one, so it's not going to be smoke and mirrors. I just wanted you to show you this one so that you can see that I'm going to come back to this AKS demo cluster here. But to create a cluster, I'm going to come down to your two containers in all of my resources, and I'm going to create a resource and go to containers and select Kubernetes services here. Now, when I create this, you basically just pick any resource group and then give it a name, take the latest version, and set the number of node count that you want for the primary cluster, which the node pool in the primary cluster. So that basically means that you will have at least one node pool that is going to be for Linux containers. So as of right now, the Windows only cluster I don't think is possible. So the next tab, when it comes to scale, what you want to enable is enable this right here. You want to be able to have the VM scale sets turned on, because if you turn that off, it won't allow you to have multiple node pools. So we're going to turn that on and make sure that that virtual node pools are enabled. You don't want to have virtual nodes on or off. That's for using Azure Container Instances as node pools if you so desire, and you can do that. We have another video, and I'll link that in the description so you can look at how to use virtual nodes with AKS. But turn that on, and then everything else you can pretty much leave as is if you want to, and click through this, and then once you get to the end, you can go down here and click create, and that will actually create the resource and go about creating your virtual machines, and then we'll provision those virtual machines to use the Kubernetes cluster. And once you have all that ready, you can come back into your Kubernetes services and you can create your node pool for Windows containers. Now, you can see here I've already created this, and the reason why is this does take a few minutes to do, because it does take a minute to provision the virtual machines. And once those virtual machines are provisioned, though, you can have your node pool available. So you can see here that I have my agent pool, which is the first node pool that it created for this particular instance, and I already have a OS type of Windows here and Linux for running Windows containers. So to add a node pool, you simply click Add Node Pool, and then you give it a name. It has to be less than 6 characters for Windows nodes. And you can put in any name you want. You select Windows, select the version of Kubernetes you want to be running on it, and then you choose the size of the VM that you want. Now, for Windows, you're probably going to want a little bit more of a beefy VM to run a Windows node, simply because the overhead of a Windows server is a little bit more than what you would expect on a Linux server. So for that to run on a Windows server, it does take a basic operating system. It is a headless version of Windows, so it's the core version of Windows. It's not the full desktop experience that it's going to be using under the hood. It's going to be using the more core series, but even that takes a virtual machine that's going to have some more resources than what you would expect from something that would work for Linux, because Linux has lower overhead, and then you put the Kubernetes stack on top of that, and then you put your container stack on top of that. Just right off the bat, for a Windows server, I would recommend something with at least a minimum of 4 gigabytes of RAM. And I don't know that it will let you select anything less than that in this. If I even remove all the filters, it'll let me select a DS1, which has 3.5 gigs of RAM. So minimally a B2S for a burstable VM, which will be about $30 a month. But this will be a 3.5 gigabytes of RAM, would be the smallest VM it'll let you choose. But I would recommend at least 4 for a small cluster, maybe even going up to like a 8 gigabyte machine for running Windows containers, because they do tend to have a lot more overhead than a Linux container does. But once you have that selected, and for this demo, it's like that, you can select the number of nodes you want in your pool. And I have a quota limit on this particular subscription, but you can scale that up, scale that back, however you want to, and then choose the node count and then click add. And that will go about the process of actually creating your node pool on your cluster. But I already have one called WIND, and it succeeded. It's running the same Kubernetes version as my Linux node pool and my Windows node pool. So that's how you create a node pool, and that's what and with an AKS cluster in the Azure portal. And you can do this from the CLI as well, and there's instructions on Microsoft's documentation on how to do that if you want to do it that way. All in all, though, that's very easy to do in the portal. And once you have this up and running, you can then use your IDE to deploy containers to this node, and I will show you how to do that using Visual Studio 2019 with Docker support enabled. I'm here in Visual Studio 2019, and I have before me an application that is written using ASP.NET 4.8, and this is .NET framework, full framework, not the .NET Core. So this is a full-blown .NET framework application, so it will only work on Windows. And I did this on purpose because I didn't want to use a technology that could work on Linux. So anytime you're working with container technology, it's always best to prefer Linux containers. If you can't use them and you need to use Windows containers, that's certainly a possibility. But if an application can run on Linux, it's always going to be better to do that when you're working with containers. But having said that, I'm going to do a demo using this application, which is a .NET Full Framework application using Windows containers. And this will deploy into a Windows container that is using one that is pre-built by Microsoft. And I'm basically adding some my application onto that pre-built container because I don't need to really work on getting that container provision to run these when Microsoft has already done that. And that is one of the great features about Visual Studio, is it's going to do a lot of that plumbing for you. So let's just run this application and see what it looks like on IIS on my local box here. So I'm going to switch to IIS Express and go ahead and run this application on a Windows host, which is my dev machine here, which is really just a virtual machine where I've installed all the stuff to run. Now, before you run this, a couple of things you'll need to have is Visual Studio installed. You'll need to have it provisioned for web apps, and then we'll look at Docker for desktop here in a minute. So all this little app does is adds numbers, subtracts numbers, multiplies or divides, and you can do whatever to do these calculations. And with each one of these button clicks, it does a post back to the server, does the calculation on the server, then updates the form. So it's a very basic application, but it is using server-side processing to do this. You could do everything I'm doing here in a browser. I know that, but I wanted to use this little web forms application to demonstrate containerizing an application and then putting that up on a server, in that case, Windows. And this app is compiled, it runs, everything is very easy to use. The code for it is very elementary, so I'm not going to go into that. It's just doing some add, subtract, multiply, and divide. And once I have all of that ready, I could then have my application containerized automatically using Visual Studio for Windows containers. Now, to do that, the first thing you'll want to do is install Docker for Desktop. And Docker for Desktop is the Windows platform for doing Docker development, and you'll want to make sure that your Docker for Desktop is set into Windows container mode. So if you see on the context menu from your tool tray, switch to Linux containers, that means you're running in Windows containers. If it says switch to Windows containers, that means you're running in Linux mode. So make sure that you have switch to Windows containers and on if you're running in Linux mode, and that will start up a virtual machine behind the scenes that is using Windows containers. And once you have that, the next thing you want to do is for your project, if you didn't do it when you created the project, is add Docker support to that. And you can easily do that by going to add, and then you can click on add Docker support here. Now, you can also click on add the container orchestration support too, and it only supports Docker Compose for this particular version, which if I was using Docker Compose, I would do that, but I'm using AKS, so I'm not going to be adding container orchestration to this particular application. I'm using AKS to deploy this, so I'm going to be using Kubernetes. But once you add Docker support, this will allow you to generate a Docker file, and this is an automatically generated file that will build my application for me. And it's parameterized here to inject some stuff into it. So it's using a container from Microsoft here that I didn't build. So that's a base container that Microsoft is supplying to me that I can use for my full framework applications. And so this is a Windows Server Core application running on Server 2019, and is against ASP.NET version 4.8. So this is a container provided by Microsoft. There is one for basically every version of .NET that you can think of out there on Microsoft's container registry. So if you can go out there, you can grab that. You can install that if you need to. Your app, Visual Studio will automatically detect what version you need, so you don't have to actually manually select this. So all I did is add Docker support, and it generated this Docker file for me, and it selected the appropriate container image for my application to run in. So I had to do nothing for this to run. It simply just works. Now, whenever I want to run this locally, I simply come down here and select from my run menu here where I want to run this. So I can select run in my local context just like I did, or I can select Docker. And then what that will do then is that will then build a Docker container and run that locally. And this will then generate a container, and you can watch that get output here. Now it's giving me forbidden because I don't have list enabled, but if I go to webform 1.aspx, that will pull up my application inside of my IIS running inside of my container. So that's the container IP address, and that is the actual endpoint that I'm going to be hitting the web page, and I can put in whatever value I want, add, subtract, multiply, divide, and you can see that it is actually doing the math. In this time though, on a Windows container on my local box here. So I know that it works in a container. I know that it works in a local context. So let's go ahead and push this up to a container registry, and we can do that very easily. So let's close out my browser here. So once I have this, once I have this application ready to go, and I know it works in a Docker container, I can publish it directly to a container registry right out of Visual Studio using the publish feature. Now, if you're doing it for a more production-oriented application, you would definitely want to use a DevOps pipeline to handle this. However, I'm going to use the right-click and publish option here right inside of Visual Studio to go ahead and push this to a registry to expedite that process. Now I can do a DevOps pipeline by checking my code in and using triggers, and we've got a couple other videos that look at how you can use triggers, and you can use ACR to build images. You can use Azure DevOps to build images, or you can use GitHub Actions, and I'll link all those in the video description below so that you can check out all of those different DevOps tools that are integrated with Azure Kubernetes Services for deploying containers to them. So now that you have this published, I'm going to actually delete this one already here to show you how to create this. So once I come down here to publish and I right click on publish, I'm going to click start. Now I can publish this to an app service on Azure. If I want to do that, I can put it on Azure Virtual Machine, FTP it to an IIS instance of whatever. What I really want to do is put it on a container registry. And notice it gives me a couple of options here. I can put it on a container registry on Azure. I can put it on an existing container registry, put it on a Docker one, or I can put it on a custom one. So if I have something like Artifactory or something like that for hosting Docker images, I can simply use that. But I'm going to use Docker Hub for this demo, and I'm going to click create profile, and then I'm going to punch in my credentials for Docker registry. And this is a personal registry since it's mine, and I'm going to hit save. And then it's going to create everything I need to create this particular publish to my container registry. So I'm going to click publish, and that is going to, yes, I want to stop debugging, and that's going to actually publish this out to my container registry. And you can see that it's going through the build process, and it's going to push all my layers up. I've already actually published this, so it's really going pretty fast. I didn't need to re-push all those other layers that it creates whenever I have a Windows container. I simply just need to put the deltas in there, which was basically everything that was generated by this particular Docker file. And so once that's done, I am ready to publish this. But let's go out and take a look at what is actually out there on my Docker Hub. So I'm going to go Docker Hub Blaze, and that usually links to me because that's my registry here, and I should see a new application, web application 4 or application 1 right here, and tags here. It's just got latest as well, and that I just published that not too long ago. A caveat with running these kind of Windows containers is they tend to be pretty big for containers anyway. This one's 3.2 gigs for basically a Hello World application. So it's rather large. That's one of the caveats of using Windows containers, is that the images tend to be big. But the thing about Windows containers though is the base images are shared with all other Windows containers. So once you have the base layers for a Windows container on your server, anything that is using that base container will use that same base image. So once it's downloaded once, and you don't have to download it ever again. So you're not going to be downloading that on a per application basis if you have a bunch of Windows applications that you're running. That's just a caveat of using these though. You can accomplish the same thing with Linux containers. If you use the same basic base container for all of your Linux applications, you can have a single large base image and then use that to power all of your other applications. But once you have all that ready to go, the image is up there, everything is ready to go, and we can now deploy this actual image to Kubernetes. And to do that, I'm going to use my Kubernetes manifest file here. I created a YAML file inside of Visual Studio, and this YAML file has, as part of it, a load balancer, which is a publicly exposed IP address exposing this as a service on port 80. And then behind that, I have a deployment with a single container, a single replica. I could put more than that for this particular app, but for this demo, that's all I need. And I'm pointing to that image that I just showed you in Docker Hub, so Blaze/web application 1. Now, the main thing that I need to do to make this work with Windows is add a node selector here. So to make this node selector work, I need to add this line here, and then add this piece of information here so that the deployment will be forced to go to a Windows node. Now, Kubernetes is not going to be able to detect that by default, so it needs to know which node to use. And so what this is basically telling this to use is a Windows node. And so whenever you create your AKS cluster, it's going to create a node with this label on it. And then as part of that label, that value is going to be Windows. And so it's going to force this onto Windows nodes as well. So that's all I really need to do to make this work, other than the typical standard stuff that you would otherwise do with a Kubernetes manifest file. So once I have that ready to go, I can launch my command prompt, and then I should be able to use command. I could use kubectl to create this. So I've already got this up and running. So what I'm going to do is I'm actually going to remove it with kubectl and then re-add it. So I'm going to grab this folder here and then cd to it, and then I'm going to do a kubectl delete -f app, and it's going to remove those services that I already had up and running on my Kubernetes cluster, because I already went through this deployment process. I did that to make sure that the container downloaded. The image is already on there already, so that I can then deploy this image to my Kubernetes cluster, and it will actually come up more quickly. Otherwise, it would have to pull that large 3.5 gigabyte image down to my local context for running that image on Kubernetes, and that can take a while, depending on the speed of your internet connection and all the other factors that go into that. But once I have that, I can then run kubectl create -f app -yaml, and that is going to create my application. So to make sure that this works, I'm going to do a kubectl or get pods, and it's creating the container. I can do a -follow or watch, and that will tell me when it's running. So it's actually already up, because that image was already pulled to my local instance of Kubernetes, which is running up on Azure. And so with that, I can look at my services and get the IP address for this particular demo here, which is running on this port and this IP address. And there's the internal IP address for that particular deployment. And I can grab that, and then let's go over here to Edge, and let's launch a browser, http:// paste that in, and do web form1.aspx, and this should launch this on my application running up on Azure Kubernetes Services. So there is my deployed container. I can put in some value. That will give me a message, hey, put some correct values in there. Hey, please enter values in, and there's my error checking, and I can't add those. And I need to put numeric values in here, otherwise it doesn't work. And so there's my application running up on Azure Kubernetes Services in a Windows container now, and that makes life a lot easier for deploying Windows applications into a Kubernetes cluster that is a managed cluster on Azure. So a very nice feature. Thank you, Microsoft, for putting this out. Look forward to all the new exciting features that will be coming out related to Azure Kubernetes Services and Windows containers and everything else in the Kubernetes space. Thanks for watching this edition of Tech on Fire with Blaze. Next week, we're going to be picking up with our series that we've been doing on Windows applications and desktop applications inside of containers, and I will show you some tips and tricks on how to do that, and we'll definitely be looking at a deep dive into that stack and all the interesting things that you can do with containers therein.
If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.